Some of you saw my recent email from Friday back and forth with Matt Lupke regarding some of the advanced event logic and processing functionality with EM7, and I was asked to explain a little bit of what I was doing. So let's briefly walk through the event definition and configuration and talk about some of the finer details. On the system here you see three Cisco routers, Logan, Manchester, and TF Green. What I wanted to do here with Manchester was, well, with all three of them, was to turn on syslogs and traps and start creating some practical event policies from these things. Traps and syslogs are a little bit different from the normal SNMP events that we work with insofar as not being internally generated. We need to do a little bit of additional configuration work to turn them into useful events that have practical event message text in them and have other things such as the ability to auto clear. And this kind of went to one of the problems I was having that Matt helped to explain and clear up my confusion on. What you can see here is when I turned on syslogs on my routers, I started getting all of these lovely syslog messages in. In fact, we can just filter on syslogs, and you can see there's quite a few of them in here, running from OSPF adjacency losses and restorations to multicast and link and line problems and other things like this. You can also see with the syslogs that there are a variety of severities that are listed in the severity column for each one of these. Interestingly enough, the adjacency loss for OSPF comes in as an error, but the restoral comes in as an emergency. So I'm sure there's a reason behind that, but I don't know what it is from Cisco's perspective. So I just decided to take, since the OSPF one was a good one, I could have done interfaces, but that's kind of been done already with our internal collections. But we're not really doing anything with OSPF in a way that's as practical as this example showed. So I said, well, since we have a loss and since we have a restoral, that's a perfect use case of what we can do for detection as well as clearing the event when it comes through. So I said, well, let's go ahead and take this specific case and create a policy from it. So let's click over on the event policy definition. You can see here I've got an adjacency loss and an adjacency up event classified as a major and a healthy respectively. So let's take a look at the major first. This one comes in from a syslog message. I just clicked on the pencil on the original message, and that brought me into the editor here and pre-populated the example text down here. So this is extremely useful. I try to put an example in all of these traps so the user can see what I began working with originally. In this example here, we see it comes in from the device name, a date timestamp, a Cisco standard percent, and then sort of a feature set, severity, and then shortened message, colon, and then a longer message. And so this is really what I want to work with right here, because this tells me the OSPF process ID, in this case 100. I don't really care about that, but I do care about this this right here. This neighbor IP tells me who the neighbor is, which neighbor it was that dropped on which interface. In this case it went from full to down. The dead timer expired in OSPF. So that's what I want to parse, and in my case the piece I want is right there, because I want to tell exactly which neighbor it was that dropped and not overload the user with all of this stuff. I could pull all of this text here out, but that doesn't really do me any good. It's just too much information. I probably already know there's a problem with this interface, but I really want to pull this specific neighbor IP out of here. You'll notice that in the event message here that I'm using some text, and then I'm using % uppercase I, which is going to use my identifier. So with that, let's click over on the Advanced tab and see how I structured the remainder of this. The first match string is important. This is required for certain event types, specifically those events. If you look at the little mouse over here, it's specifically required for Syslog's API and email events. So if it's an internal event, then we know it generated it because it's an internal event. If it's a trap, we know it generated it because it's going to have a trapoid. But in the case of Syslog, we don't have any inbound information that explicitly identifies a specific event. And so we have to use the first match string at least, and in my case you can see I'm also using the second match string. So basically I said if a syslog message comes in for any facility, and I could have been specific here, but I wasn't, for any severity, in this case it's coming in as a notice, but I could have said match any, but this is standard for Cisco. I think this is going to do a notice or above. And it has the first match string of %OSPF5 adjacency change, then I care about it. But in this case, if we go back to the original messages that were coming in, and these are my messages that were coming in, my syslogs, then the problem that would cause is that both the adjacency loss as well as the adjacency restoral would be matched here, because they both come in with an OSPF5 adjacency change first match string. And so I'm using the additional filter 2 down because my first message came in here, it says full 2 down. And I said, no, that's fine, I don't really care about the full, but if it's 2 down, then the adjacency has been lost. It could have been from init to down, theoretically. So I simply said, well, if it's from any other state to the down state, then the adjacency is lost. Then I'm using this very brutal regular expression here to pull out this IP address from the event message. So this regular expression is saying if I have any string at all, dot star, plus then I have one or more instances of white space, that's the backslash s plus, and then digits dot digits dot digits dot digits followed by some white space, then I care about this. But you'll see I also have these parentheses in here. And what the parentheses are going to do is create what we refer to as a back reference. And this back reference then allows me to take whatever this specifically matched and reference it down here. So if I had 2 back references in here, let's say for example I also wanted to capture the interface that it was on, then I could have continued my regular expression code up here and simply done another set of parentheses around some other bit right next to it here, and that would have been %2. That would have been my second regular expression back reference. And the reason that this is important is because this %1 then becomes the content of the identifier format. And it's the identifier format that is what is substituted here into %I. And so I use that regular expression to pull out this, specifically this IP address, actually the first incarnation of any IP address in this string, and put that into %I. And the way that we can check this is to take my inbound text here. I'm just going to Control-C and copy that into my copy-paste buffer. Go to my toolbox regular expression tester and paste that into the search text, and then go back into my event policy definition. So this is what I came up with for a regular expression right here. And so I'm going to put that regular expression into the regular expression field and test it. And what you can see is that it's going to apply this regular expression to this text, and it's going to pull out the subpattern that you see referenced right here. So subpattern 1 does the proper match for what I'm looking for out of this big long chunk of text up here. And so that's exactly what I want to see. So subpattern 1 is going to receive that text and put that into %i. So that's how I can pull out this IP address, assign it to %i, and do so while developing this regular expression pattern in EM7 in the regular expression tester. So once I have that, then that's going to create the events that you see here. So active events right now, I don't have any. But if I go and I shut down that interface, then within a couple of minutes, actually within a couple of seconds, I'm going to expect to see my new events come in. And I just got my first line proto down. Adjacency has been lost to neighbor router 192.168.11.3. If we go to the event console, then we can see our adjacency loss message up here. And we've actually got two of them because the line that I just took down connected Manchester to TF Green. So each of them lost his adjacency. So I got two event messages here, one for each router. So this is exactly what I would expect to see. And the only thing I would add on top of that is, again, if we look at the advanced settings here in the event policy, you'll also see that I defined an event category called network connectivity. And I defined that event category in registry events event categories down here, specifically for the purpose of grouping different events, so that if I have other events such as certain kinds of interface down events, then they will get subgrouped underneath, they'll get suppressed underneath these parent events that you see up here. Sometimes in my demo environment they fire, and sometimes they don't. But if they did fire, then you would see them under the magnifying glass here as suppressed events. So I just brought that link back up on my router, and shortly here I'm going to expect to see the clear events come through, and they both are. So event OSPF adjacency has been restored to 11.3 and to 11.2. And if we go back and look at Manchester, then you'll see the restoral up here, and we'll see the restoral up here. You can also see that I've got some nice candidates down here for multicast. These are coming in as notices for link up, down, and for link changed. So you can see that I have a different message here for when I shut down the interface administratively versus when it gave me a state change event. So they do actually very nicely separate those two. So these would be good candidates for writing some additional Cisco Syslog message events from. But I hope this was helpful. Talk to you soon, guys.